November 7th was International Inuit Day. Around the world, Inuit, indigenous, and rural communities face the same challenges. Limited access to power, language barriers between communities, and remote locations that make communication exceptionally difficult. Yet, they harbor the same goals as any other society here on this earth. The goals of survival, prosperity, and sustainability. In Calgary, I can reach someone 10 kilometers away with the click of a button. This has allowed us to share across cultures, across communities, to grow our economy, and to build a country that is sustainable, inclusive, and resilient. But across the world, in Northern Canada, in Sub-Saharan Africa, many societies do not have access to the same opportunities. So to answer this question, we developed telepod. It's a hardware-software solution for connecting settlements through accessible, decentralized, AI-powered communication technology. For an overview of our hardware, first we have a single board computer. This can be anything from a Raspberry Pi to other boards that have the same functionality. And this is connected to an ESP32, which supports the LoRa protocol. This is a long-range communication protocol where these modules are able to reach ranges of up to 10 kilometers between villages. This is connected to a speaker, which allows the entire box to act as a sound-generating device, which is then connected to a microphone that inputs the user's messages and responses with an LCD screen, which we'll touch on later. And then this is also, for another piece of input, a push button, which will prompt the user. And then we also have a status indicator LED and some modules that allow us to keep the pod in normal working operable conditions. It's connected by serial to our long-range communication module. So when we receive an input via the microphone of the user's message, what they actually want to communicate with the other community, it will get converted to text and then sent over to the ESP32. The ESP32 then communicates via the mesh network to other nodes in the telepod network, which allows us to receive a translation from the server. So for example, we would be translating this text to another text to help us circumvent language barriers between different remote communities. This would then get sent back to the single board computer on our telepod, which would get broadcast to the user via the speaker. We also have a GUI using Pygame to allow easier interaction and accessibility. And both modules here use an AI module in Python.
Our software consists of 4 interconnected layers that work together in order to do the analysis of which villages match up with other villages and then distribute that information to our local telepods. At our core, we have a PostgreSQL database hosted on Railway, storing all village profiles with their requirements and materials and resources that they have. And from there, we have an Express.js REST API that acts as kind of a gateway to handle all operations, creating villages, everything to do with REST and CRUD. It's also where our OpenAI GPT-5 integration lives, providing intelligent query interpretation and village matching based on NLP. For our AI-powered assistants, we also have an MCP server that connects with this GPT-5 implementation so that when the AI wants information, it can easily query for information both from our database and in the future, it would have the ability to do web scraping or look for information from outside databases in order to supplement our AI as much as possible and find the best villages for us to match with.
And now we will have a live demo. Now this demo will be set in an example situation where we are inside a French-speaking remote community in the African country of Senegal. And we want to request the aid of an English-speaking doctor which is stationed at another village 9 kilometers away. So here we have our microphone. This is our actual telepod module hardware itself. We also have a LoRa antenna. This is the status LED. All the wires will go inside. This is our button. If you open it up here, we will see we have the communication software. This is the speaker. These are all these wires, and then we close it up. This is the solar panel. There is also battery functionality that we haven't implemented yet, but if we were to use this at night, it would be sustained using the batteries which are charged before. So, if I were to, Jerry, can you hold this? If I were to speak, and I am the citizen who wants to request a doctor, it says here in all 3 languages we have as an example, we have English, Inuit, and French. And for example, I will speak French now. J'ai besoin d'un docteur pour ma bras. And I'm asking for a doctor to help my arm. So as you can see, it sent this. It says message sent. And then if we come over...
Notre équipe médicale peut vous assister immédiatement. Touba, New Bell Region, Senegal, 4.00.
So as we can see here, if we come back to the server, now this server would be in a position with Wi-Fi, so we can access to our API. And again, it would go node by node by node by node until we reach that city from the villages. And we can see our team of medical assistants will be coming as soon as possible from the Diourbé region in Senegal. And again, it's spoken out here in case we do not have citizens who are literate in French, they can still listen to the response from the other village. Thank you very much for listening to our presentation.